All right, so today we're picking up fractions again. Now, we've looked at some fraction operations already this year. We looked at multiplication earlier, we looked at division earlier, but today we're specifically looking at addition and subtraction of fractions. So, for that first one, we're going to start by doing 3/8 plus 1/8. Now, some of you can just look at that and you can know the answer, which is excellent. Do you remember why it works the way it does, though? Like, in order to add fractions, what do you always need to have? Common denominator, right? Do you remember why that is? Let's take a look and see. So, this is a very classic representation of a fractions where we've taken some amount, so like this bar here represents one whole, and we're just breaking it up into eighths, because of course these are all pieces of 8. So that first fraction, that's 3/8. So that means I'm shading 3 of the 8ths. And then I'm adding to that 1 of the 8ths. Hence why, when I put them all together, the whole thing does equal, yes, 4/8. But notice I could only do that. I could only put those together if all those pieces are the same size. If they were different sizes, I couldn't do it. Hence why we have to have the same denominator in order to actually do the addition there. Now, one other thing I want to show you. We can reduce our answer here, right? What does 4/8 reduce to? 1/2, right? So notice that it equals the exact same thing as 1/2. Well, remember what I do to the 4 and the 8 to make it into 1/2? It's like I'm dividing top and bottom by 4. That's the actual work we're doing to it in order to make it into the 1/2. Well, basically what I'm doing is I'm getting rid of those 4 divisions that are inside of that whole thing. So instead of having 4 individual pieces, it then turns it into 1 piece, which makes it a little bit easier to look at then. We can actually see how the same shading gives us the 1/2. So, algebraically speaking, when we're doing this, you add the tops and the bottoms, or I'm sorry, you add the tops and you keep the bottoms the same. There, I can say it right. And the bottom stays the same because that's the only way we can actually put these pieces together. And then reduce your fraction. And if you got that idea down, then the rest of this is going to be straightforward. So for the second one, it's subtraction. But of course, subtraction is the same idea as addition. So we are going to start by subtracting the tops. If I subtract on the top, 3 minus 1 gives me 2. The bottom, remember, stays the same. Because I have 3 8s. So I have 3 of these things that's each 1/8 big, basically. And what it's telling me that I'm doing is I'm taking away 1 of them. And hence why it leaves me with 2 of these things, each of which is an 1/8. Now, of course, this one's not done either, is it? No. It also reduces. What can I divide top and bottom by? 2. Yep. So we divide top and bottom by 2, and we get a final answer there of 1/4. Next 2 problems, multiplication and division. Well, these we saw earlier this year, so let's check and make sure you remember those. Go ahead and do those on your own first before we do them together here. All right, so for the multiplication, remember our rule with multiplication is you're going to multiply straight across the top and straight across the bottom. So on the top I do 3 times 1, which is just 3 of course, and on the bottom I do 8 times. And so that's going to be 3 over 64. Now, does that reduce? Well, if we're trying to do this without a calculator, there is a trick to be able to know if it reduces. Do you remember how to tell if a number is divisible by 3? Remember, you can actually add those digits together. This only works for multiples of 3, but you can do that. What's 6 plus 4? 10. Is 10 a multiple of 3? No. Then neither is 64. It only works for multiples of 3, but it does work for this. So it's an easy way to tell if it is divisible by 3 there. All right, and then for the last one there, our division. Remember, division is the one where we have that one special kind of funky rule there. This is the one where we multiply by the reciprocal. That is, you change the division to multiplication, and at the same time, it has to be the same line, you flip the fraction. And it's always the second fraction that you flip. Never the first, always the second.
Why can't it be the first?
And so when we do that now, I multiply straight across the top and straight across the bottom. So I get 24 over 8. And then does that reduce?
Yeah.
Yes, it does.
By 8.
I can divide both top and bottom by 8. Now, of course, 3 over 1 just equals 3. And so that's going to be our final answer, is just 3 there.
The 3 over 1 is 3.
So on this second problem, we do the subtraction, and we subtract straight across the top, but in this case, that gives us a negative 1. So you have negative 1 over 6. But that's not normally how we present that as an answer. We normally don't say negative 1 all over 6 like that. The negatives aren't normally in the fraction for that reason. And so, how do we deal with it? Well, remember, a fraction is the same as division. What is a negative divided by a positive? A negative. And so we can actually just put that negative out front. And so the whole thing is actually just a negative 1/6. Right, and then we move on, we do the multiplication, straight across the top, straight across the bottom. Does that one reduce? Yeah, it does. We can divide out of both 20 and 36. We can divide them both by 4, which gives us then a final answer of 5/9. And finally, for that last one, 4/6 divided by 5/6. Multiply by the reciprocal, remember. So when you flip the fraction, you always flip the second. So it becomes 4/6 times 6 over 5. A little reminder here. Notice we are not doing this. We are not cross multiplying. We only cross multiply if the fraction is equal to the fraction. It'll feel very similar, but if you try cross multiplying with this, you actually can end up with an answer that's flipped upside down very easily. And so that's why we don't do that. All right, now that's a multiplication problem. We multiply straight across the top, straight across the bottom. And you notice we can divide both of those by 6. And so we do. You get a final answer then of 4/5.